All right. Let's take a look at the next one here. So first thing we have to do is show that the function is continuous, but you'll notice there's a value we can't have in there. X cannot be equal to 0, and that's in the interval. So therefore, we can't use the intermediate value theorem because f is not continuous. So on this one, f is not continuous. Therefore, IVT does not apply. Easy peasy. Like them all like that. They won't be, but like them all like that. All right, let me check this out here. Okay. So now we have a function. So this is kind of the same question over and over. They're just going to phrase it differently. So I tried to give you a whole bunch of different possibilities here so that you had a lot of practice and a lot of different examples. So excuse me, the function h of x is continuous on the interval from -3 to 7, with h of -3 equal to 10 and h of 7 equal to -2. Is there a guarantee that there is some value a in the domain such that h of a equals 1? Anytime we do an existence theorem, the answer is always yes. So yes, there is a guarantee. So yes, since h of x is continuous on the interval from -3 to 7, and you could go ahead and do the calculation here, or they gave us the calculation, and h of -3 equals 10, and h of 7 equals -2, and I'm going to write it slightly differently this time. The IVT, intermediate value theorem, guarantees there is some value such that h, and they give us the letter a, so I'm going to use that, h of a equals 1. So they said 1. Let's just double check. Is 1 between 10 and -2? It definitely is, because -2 is less than 1 is less than 10. I wrote a little differently. You get the idea across, though. All right, so now we're going to verify that the intermediate value theorem applies to the indicated interval and find the value of c. So we actually have to find the c value. So we're going to do kind of a little proof first, and then we actually have to calculate the c value, which was our second I can statement tonight, or today. So we're going to start by saying, first of all, is that a function continuous? So yes. So since f of x is continuous on 0 to 3, and let's go ahead and do this calculation. I'm going to do my calculation off to the side. F of 0 equals 0 squared minus 6 times 0 plus 8, which equals 8. And then f of 3, so I'm plugging my x values in, 3 squared minus 6 times 3 plus 8. And when I add all of that up, I get -1. And just double checking visually, is the value that they want 0 in between those? Absolutely. So, and f of 0 equals 8, and f of 3 equals -1. The IVT guarantees that f of x equals 0 for some value of c, because it's between -1 is less than 0 is less than 8, the y values. Now, I haven't finished yet because I have not yet answered find the value of c, so I'm going to do that next. So what I'm going to do is, if it basically says I'm going to take this guy and set it equal to that y value there. So x squared minus 6x plus 8 equals 0. Looks like a good old magic x to me. So two numbers that multiply to 8 and add to 6. I'm thinking 4 and 2 looks like they both need to be negative. Okay, and then we use good old zero product property. So x equals 4 and x equals 2. Now, To get our actual C value, we have to double check to make sure these are actually on the interval that was given. So 4 is not between 0 and 3, so 4 is not our C value. Our C value is this 2 because it is on the interval. So C equals 2, and I'm just going to write a reason. You don't have to, but I would write this down for your notes because 4 is outside the interval from 0 to 3. All right, we're going to keep going. So we are we're verifying again, and we're finding the C value. So it's another one we're finding the C value. So I'm going to go ahead, and I know I've got to do this calculation anyway, so I might as well just do it at the beginning. So I've got to put in f of 5 halves. I'm putting 5 halves into this mess, which is truly a mess. So we've got 5 halves squared plus 5 halves over 5 halves minus 1, which is really, I could rewrite as 2 over 2. 5 halves squared is 25 fourths, and I'm going to make this into fourths, so that would be 10 fourths over 3 halves. This equals 35 fourths. And then instead of leaving this down here, I'm going to flip and multiply in the same step here. And it looks like 2 can go into 4 twice, so I've got 35 sixths, which if I take 6 and go into 35, it goes in there like 5 point something times. All right, let's put in the other value. So f of 4 equals 4 squared plus 4 over 4 minus 1. Much nicer numbers, so 16 plus 4 over 3, which would be 20 over 3, which this is like 3 goes into 20, like 6 point something times. So what value were they looking for? They wanted us to get 6. So 6 is definitely between 5 point something and 6 point something. So we know that this is going to work. So first thing we state, we have to be continuous in the interval because we know that it's not continuous at 1, but 1 is not in between 5 halves and 4. So with the interval we have, it is continuous. So since f of x is continuous on the interval from 5 halves to 4, and f of 5 halves equals 35 sixths, and f of 4 equals 20 thirds, the IVT guarantees f of x equals 6 at some point c. Actually, f of, some point c, because I'm just going to go 35, 6 is less than 6 is less than 20 thirds. Now again, that's the first part of it. We still have to find the value of c. All right, so I'm going to take this guy and set it equal to 6. So I've got x squared plus x over x minus 1 equals 6. I'm going to take this and multiply it to the other side. So x squared plus x equals 6 times x minus 1. I'm going to distribute. So 6x minus 6. And it looks very quadratic to me, so I'm going to move both of these to the other side. So I keep the x squared. When I subtract the 6, I get negative 5x. When I add the 6, I get plus 6 equals 0. Good old magic x problem. So two numbers that multiply to 6 and add to negative 5 would be 3 and 2, and it looks like both negative. So x minus 3 times x minus 2 equals 0. Get out the good old zero product property. Set them both equal to 0, so x has to equal 3 and x has to equal 2. Let's see, is our c value, are they both valid for our c value? Well, 5 halves, isn't it 2.5? The same thing, 2 goes into 5, so 2 is not in between there, but 3 is. So c equals 3 because 2 is not in the interval between 5 halves and 4. All right, one last problem here, and I want to make sure I show you this one. Oh, maybe not. I think there's 2 problems actually. There are 2 problems left. So I want to show you example 8 for sure because your assignment's going to come a lot out of Delta Math. So I want to make sure you know how to state this in Delta Math. So the function f of x is continuous in its domain between -9 and 9. Given that f of 2 equals -5 and f of 7 equals -2, determine what conclusions can be drawn based on the intermediate value theorem on the interval from 2 to 7. So we basically need to state that it's continuous. So we would say since f of x is continuous, and you'll have to put that word in there because they gave it to us, on whatever domain they give us, the IVT can be applied. And a lot of this is like drop down stuff you can just put in. And then it says something and states that for any value k, and this is a little bit different than the way we were phrasing it, any value k in the interval, so in this interval that they gave you, there exists a value c where, they're using where instead of such that, and then you want to tell them what the y values were that they gave us. So that's between 5 and 2. So -5 less than c less than -2. Such that f of c equals k. And then they're going to give you some other information. So then they're going to say, oh, they ask, must there exist a value of c in the interval where f of c equals, oh, they're going to give you another question. So it says, must there exist a value of c in the interval from -4 to 4 where f of c, where f of c equals 0. And because that is between, is it between the, no, I wouldn't say 0 in this case. I'm copying a different problem. So let's say f equals -3. And it would be yes, because not only is it between in here, but because we have all this guarantee of the IVT. So it would be C, so you would say there exists is the answer, okay? And then they pretty much give you the rest as a fill-in. All right, let's look at this last one. And this last one is an AP level problem. There's some goofiness stuff in here. You don't really need to worry about it. But it's good to see one of these off of a table because this is what we call a tabular stem, because this is the stem of the problem and it has a table in the stem there. So the functions f and g are differentiable. Just checking to make sure I'm still recording. So differentiable means continuous. You don't need to worry about that word right now. Just know that it means continuous. Eventually, you'll learn that along the way. So for all real numbers, g and g is strictly increasing. The table above shows the values of the functions at their first derivatives and its selected values of x. You don't need to worry about what derivatives means yet. The function given by h of x equals f of g of x minus 6. So we're supposed to explain why there must be a value r. So see how those words must be? That's an indicator that you've got an intermediate value theorem problem for between 1 and 3 such that h of r equals -5. So we're going to first of all state that we know that because it said that f and g are continuous, so therefore h has to be continuous. So h of x is continuous. Okay. And then we also need to do this calculation here of what the values are that are on with these r values, which are really going to be like x values. So we do that calculation off to the side here. So h of 1 equals f of g of 1 minus 6. So this is where the table comes in. I need to find g of 1 on the table. So g of 1 is 2. Now I need to find f of 2. So f of 2 is 9, and 9 minus 6 is 3. Now I need to find h of 3. And I have to make sure that -5 is between these two numbers. So f of g of 3 minus 6. So f of g of 3 is 4. And then f of 4 is negative 1. And good news, we know that negative 5 is between negative 7 and 3. So we're going to finish up this statement. So explain what, so h of x is continuous. So we would want to say the IVT guarantees, actually, wait a second. I want to write down something else before that. And h of 1 equals 3 and h of 3 equals negative 7. There, the IVTs, oh, we want to write since. There. The IVT. The IVT guarantees at least one value, I'm putting this in the context of the problem, R, such that h of r equals negative 5. It's continuous, I missed the interval, so on 1 to 3. Should probably make it closed. Such that h of r, because, and then we want to put negative 7 is less than negative 5 is less than 3. And that concludes the lesson for the day.